How often have you heard that music? That's the #1 way to generate music electronically. Feedback. See, the sound comes out of that speaker and back into this microphone and around and around and around and around. And the amount of time it takes to go around once determines the pitch, the frequency. An audio oscillator is really just an amplifier with its output connected to its input through some sort of a delay, like this. And if you vary the delay, you vary the pitch. So why doesn't it sound like a violin or a piano? Why doesn't a piano sound like a violin? Lots of reasons. #1 is that characteristic of the instrument's oscillator. A reed, strings, lips, all vibrate in a different fashion. Whistles, flutes and things, vibrate in a very pure form. That's sine wave. But reeds vibrate in sort of a rough form. The less the oscillations look like a sine wave, the more harmonics are present. Harmonics are little multiples of the main frequency, 2, 3, 4, 5, 6, 7 times that frequency, mixed back in with it. They give it a little kind of a jagged edge in different shapes. Those can be simulated electronically with different waves. These waves all have the same frequency, but different groups of harmonics. The body of an instrument also contributes to that by emphasizing some of the harmonic frequencies and de-emphasizing other ones. The body is very important to the way it sounds. Further sound control can be had in a synthesizer with filters. Notice as I vary the filter, I remove different groups of harmonics out of there. The fundamental stays the same. There's the same spacing between the repeats of that note, but the shape changes drastically, and so does the sound. The last thing to simulate a real instrument that's important is its attack, sustain, decay, and release. That means what happens after you pluck it, bow it, or hit it, what goes on. When you bow a violin, the sound starts out at one volume when you start bowing and continues along at the same volume until you finish. A piano, on the other hand, when you hit the note, starts out loud, starts to die out gradually, and then when the note is released, dies away suddenly. A guitar string might start out loud and die smoothly to a final value. All things kind of decay differently. That can be simulated electronically by hooking an amplifier to the keys to control the volume as the keys are hit. Here's a long sustain, shorter. It's variable over a wide range. And unlike natural instruments, their attack can also be varied to be kind of slow, giving it that sort of delayed sound. Those are the elements of synthesizing a musical sound of an instrument. A keyboard whose pitch can be controlled, different waves and filters to simulate the harmonic content, the timbre, the sound of an instrument, and an amplifier that automatically varies the volume in order to simulate the attack, sustain, decay, and all of that stuff. Now, synthesizers also contain other stuff like circuits that will change the frequency automatically of the notes and change the filter automatically and add noise and all of that stuff. But there's a problem. They only play one note at a time. So as a solo instrument, they're not too hot. But if you take them into a studio and put them into a multi-tracking machine and put them with a computer, they can do some amazing things.